Okay, the last model is with fewer predictors. So instead of using all the predictors, we're going to just select um, what we consider are the most important ones. So here is the code for, so we're going to create a new variable. Okay, we'll call this weekend. Okay, so we're going to transform the day of the week, okay, into, so we take delays.df day, okay. Now we want whether the day of the week is a weekend or not. So we want yes or no, or true or false. So what we can do is we'll use an operator that is in, okay, surrounded by percentage mark. So that's an operator. What that would do is it will take the value from this column and check whether it coincides or it is equal to one or more of the values that you specify. So I'll specify here Sunday and Saturday. Okay. Now when we run this code, so value of the day of the week will be checked against this list. If there is a match, then you will get a true, otherwise you'll get a false. So let's run that. Right. So if you go to delays and you go to the end, you see, let's make sure that there are some true. Okay, so there are some truths here where you have Saturday or Sunday. Okay. Similarly, we're going to set up carrier and we want only some of the carriers, say delays.df, and we'll call this carrier well, let's just say carrier 2, the second carrier, and that is delays.df carrier, and again percentage in percentage, and then give a list of carriers that you want to consider. So CO MQ DH and RU. Okay, and run this code, and once again what you will see is yes or no, okay, true or false. And then the next one is we're going to take the scheduled departure time and convert that into a morning, afternoon, or evening. Okay, or noon, or we're going to convert it into 4 different values. So delays, and we call this morning, delays.df CRS departure time, okay, in C6, 7, 8, and 9. Okay, and then delays.df noon is delays.df CRS departure time in see 10, 11, 12, 13. So it's 2 hours this way, that way. 10, 11, 12, well, 2 hours on one. Yeah, that's right. 10 to 11, 11 to 12, 12 to 12 to 1. So it's a 3 hour window. Okay. And so remember that CRS departure time has already been binned to the hour. So this will be like four different hours. The 10th hour, the 11th hour, the 12th hour, and the 13th hour are selected. And then delays.df after 2 p.m. is delays.df CRS departure time in C 14, 15, 16, 17, and 18. And delays.df evening is delays.df CRS departure time percentage in percentage. So it should be 19 and 20. Okay. All right. So let's run. We've already run the first two. So we run the rest of them. Okay. So the next we do partition. So I am going to do this. For partition and okay, so we're going to do this in a slightly different way, as you'll see. Okay, and delays. Okay, we're not going to do a selected var here, so all the columns will get selected. Okay, and then we will see how to select how to use only some columns in our training. So we have FLT2 train. So you have all of the variables, and then here are the new columns that we've created, and each delay is our target. So now we run lm.fit, right? GLM, okay, is delay. And normally what you would do is you would say, okay, that's my target, and then use all the other variables as my predictor, right? With a dot. But instead, if you want to select only some variables, then you specify those, you list them. Okay. Weekend, then you have to use a plus. All right. Weekend plus weather, right? Plus carrier 2. Okay, so why is the weather didn't work properly? Let's make sure. All right. carrier 2 plus morning plus noon plus after 2 p.m. plus evening. Okay, so that's the formula we want to use. Okay, and then the data that we want to use is flight 2 train and family equal to binomial. Okay, and then we will do a summary FLT summary LM fit. Okay, so let's run this model. So this is how you would specify uh, the columns you want to run. If you don't want all the, if it is all the columns, you just say you just enter dot. Okay, so there is our printout. Okay, now let's do evaluate. Okay, so we'll do probability. So we'll call this FLT2.prob. How about that? So then we do predict. Okay, LM.fit new data equal to FLT2 valid, and then type is response. So that way probabilities will get generated. So there it is. And then we can do a confusion matrix, and I'm going to not create a prediction separately. We'll code prediction right in. So the first thing is prediction, but what we have is probability, right? So we need this as a factor. So as factor, then we'll generate the prediction. Prediction is what? If else, right? If else FLT2 probability is greater than 0.5, okay, then 1, otherwise 0. So that's our predictor. So that's for if else, this is for as factor. So that's our prediction, and we need to specify the actual one. Again, we do as factor flight 2 dot valid but is delay. Okay, there it is. And if you want class to be positive, class positive equal to 1, will give you the sensitivity specificities will be for positive class 1. Okay, and you can similarly, I'm not going to go through the same lift charts and all that now. We have done it several times. Okay, let's do an ROC chart for the FLT2 model. So we need to run library PROC. Okay, and then I'm going to copy paste an ROC code and then make the necessary changes. Okay, this is from one of our previous chapters. So here our actual target is FLT2 valid flight status, right? and then the probability is FLT2 prob. And then the rest is good. So run that, and that is our ROC chart.